Imagine waking up one morning and discovering a crack running across your street. At first, it looks harmless. Maybe a little settling. Maybe an old road finally giving up. But then you notice something else. A building nearby is leaning. A sidewalk has dropped several centimeters. A bridge is slowly sinking. And the strangest part is that nobody caused it. The ground itself is moving downward. Across the world, entire cities are slowly sinking into the earth. Not because the planet is opening beneath them. Not because giant underground creatures are pulling them down. But because the ground supporting these cities is gradually collapsing, compressing, or losing the material that once held it up. One of the clearest examples is Mexico City. The city was built largely on the former bed of a huge lake. Underneath parts of the modern city are layers of soft sediments that can compress when water is removed from them. For decades, Mexico City has pumped enormous quantities of groundwater to supply its growing population. As groundwater levels fall, the layers of sediment above them can compact. And when they compact, the land surface moves downward. In some parts of the city, the ground has sunk by many meters over the course of the last century. That creates enormous problems. Roads deform. Buildings tilt. Pipelines break. Drainage systems become harder to operate. And infrastructure designed for a stable landscape suddenly has to survive on moving ground. But Mexico City is not alone. In Jakarta, Indonesia, sinking land has become a serious environmental and engineering challenge. Jakarta sits on low-lying coastal land, and parts of the city have experienced significant subsidence. Groundwater extraction is one factor. The weight of buildings and natural compression of sediments also contribute. At the same time, rising sea levels increase the danger. So the city faces a double problem. The land is going down. The ocean is coming up. And that combination can turn ordinary flooding into something much more dangerous. But what if the ground doesn't simply sink? What if entire neighborhoods begin disappearing because the land itself is unstable? That happens too. In some places, underground mining can remove huge amounts of material beneath the surface. When those underground spaces collapse or the supporting structures fail, the surface can sink. This is known as subsidence. Sometimes it happens slowly. Sometimes it happens suddenly. A road can crack. A field can drop. A building can be damaged. And in extreme cases, the landscape can collapse into a giant depression. Water can make the problem even stranger. In areas with limestone beneath the surface, underground water can gradually dissolve the rock. That can create hidden cavities. For years, everything above may look normal. Then the surface suddenly collapses. A sinkhole can appear. Sometimes it is small. Sometimes it can swallow cars, roads, or parts of buildings. And that is why the phrase, "the ground is eating the city," isn't completely unreasonable. The danger isn't always visible from above. A city can look stable while its foundations are changing underneath it. There is another example in the United States that shows how dramatically this can happen. Parts of California's San Joaquin Valley have experienced severe land subsidence because of groundwater pumping. During periods when surface water was insufficient, farmers relied heavily on groundwater. As water was removed from underground systems, the sediments compressed. In some areas, the land surface dropped by several meters over decades. Infrastructure had to adapt to a landscape that was literally becoming lower. Canals, roads, bridges, and other structures were affected. But perhaps the most frightening part is how difficult subsidence can be to notice at first. Earthquakes announce themselves. Hurricanes appear on weather maps. Volcanic eruptions produce smoke and ash. Subsidence can be almost invisible. A few millimeters today. A few more next year. Another few centimeters after that. And then, decades later, the city is sitting dramatically lower than it was before. Scientists can now track these changes using satellites. Radar satellites can repeatedly scan the Earth's surface and detect tiny changes in elevation. That means researchers can create maps showing exactly where the ground is sinking and how quickly. The technology is revealing something that would be almost impossible to see from street level. Cities are not always as solid as they appear. Beneath the concrete is soil. Beneath the soil is water. Beneath that can be layers of clay, sand, rock, and sediment that are constantly responding to pressure and changes in groundwater. And when millions of people build on top of that system, their buildings become part of the equation. The heavier the city becomes, the more pressure is placed on the ground. That doesn't mean buildings are simply pushing cities into the earth. But in soft sediments, the combined weight of infrastructure can contribute to gradual compression. So the modern city can actually accelerate changes that were already happening naturally. And there is a terrifying question at the end of all this. How do you stop a city from sinking? Sometimes the answer is reducing groundwater extraction. Sometimes it means finding alternative water supplies. Sometimes engineers reinforce structures or redesign infrastructure. But there is no simple solution once millions of people are living on unstable ground. The real danger is that sinking rarely happens dramatically enough to make people leave immediately. It happens 1 millimeter at a time. One cracked road. One tilted building. One damaged pipeline. One flooded neighborhood. Until eventually, an entire city is fighting against a landscape that is slowly moving beneath it. So the next time you walk through a massive city, look down. The concrete may feel permanent. The buildings may look immovable. But underneath your feet, the ground is not frozen in place. It is compressing, shifting, moving. And in some places around the world, it is slowly carrying entire cities downward. Not with one giant collapse, but centimeter by centimeter, year after year, until the ground itself becomes the greatest threat the city has to face.